Hi, everyone. Thanks for joining us today. We've got our live question and answer session with Scott Zimmerman and Mike Billars. Scott Zimmerman is the president of CLOC and co-inventor of GreenFeed. He has over 20 years of experience with numerical modeling and large databases and has a solid background in analytical measurements. And Mike Biller is the leader of our support. Mike Billars, I'm sorry, is the leader of our support team, and also has developed many of the electric and software components of GreenFeed. And he's very well known for his knowledgeable and cheerful demeanor when helping our clients. So, with that quick introduction, I'll turn it over to you guys and take it away.
Hello, this is Scott Zimmerman. Thanks for attending and listening in. Firstly, I apologize for having to reschedule this an extra week. I actually came down with COVID and was at home recovering. Luckily for me, it was not fun, but it was mild, and I feel pretty good right now. A lot of you, thank you for submitting questions ahead of time. What we're going to do is we're going to spend about a half an hour going over the questions that were submitted with the registration. I would encourage you to listen to those questions, and then once half an hour is up, go ahead and ask extra questions that we haven't been able to answer. If we're within the hour not able to get to all the questions, we'll take the questions that we're unable to answer and answer them directly by email. So go ahead and listen in. This is going to be fairly conversational, so we encourage participation. So the first question that I'm going to answer is, what is GreenFeed and how is it useful for India? So many of you probably know what GreenFeed is, but Mike had a poll question for you. So Mike, can you go ahead and run the poll? So the poll is, how would you, I can't see the poll question anymore, Mike. Okay, how would you best describe your familiarity with the GreenFeed system? So have you never heard of it? Have you only read about it? Have you used it before? Or you have a lot of experience? So go ahead and answer the quick poll and I'll cover the first question. So Mike, can I see my screen right now?
Not yet. Let me make you presenter.
Are we ready? I'll show screen.
Yep.
Okay, you can see it. So GreenFeed is a portable, more or less baiting station that allows us to measure methane and carbon dioxide, oxygen and hydrogen mass fluxes while they're using the feeder. So the feeder has an RFID system with an ear tag in it. The animal approaches the feeder. The feeder just drops enough food to keep the animal interested. Generally, it's not the total amount of food for the animal. It's just a sort of a treat. And it's modified in a dropping way that to keep the animal in the unit for hopefully around 3 minutes. And while the animal's visiting the station, we have equipment inside the machine that allows us to measure the mass flux, the actual amount of mass of gases emitted while they're eating. We have programs so we can measure the animals multiple times per day. And so each feeder can service multiple animals and measure each animal's emissions multiple times a day. And over time, what we found that if we measure these animals at least 20 times, maybe 30 times, we can have really accurate estimates of the animals' emissions rates over those times they visited, and those emissions rates fairly accurately represent the total emissions rates for each animal. The data is collected by the GreenFeed. It's connected to the internet, usually with a cell phone modem or Wi-Fi. The data goes back to a central server, and the data can be analyzed either by yourself, but also we monitor the units and make sure they're operating correctly and quality control the data. Each unit follows similar or the same calibration protocols, so everybody in the world has the same expectations in terms of calibration accuracy and what they're doing to calibrate the system, and they're all being operated this very similar ways. So the system standardized, and results from anywhere in the world should be comparable between users. So it's really a streamlined, effective way to measure emissions from animals. How can it be used in India? I would say it can be used in India the same way it could be used anywhere else in the world. It could be used for inventory of greenhouse gases, metabolism studies, the effect of different treatments on methane emissions, phenotyping animals for either low methane or feed intake, which we'll talk about in a little bit. So there's a lot of different ways that it could be used, and the way it would be the way everybody else is using them in the world. So with that, I'll turn it over to Mike for the next question.
Alrighty. Okay, can you see my screen okay?
Yes, or how do I? Matt, can you see the screen all right?
Yep.
Okay.
There we go. All right, so the next question is, what's included in a GreenFeed purchase? What support is offered? And what's changed in the new GreenFeed sensors? So we actually have two general types of GreenFeed. These are standard GreenFeed systems. We do have some other custom designs, but so the general layout are freestall or tie stall carts, and then a pasture trailer. Included in all the systems, you'll get a methane sensor and a carbon dioxide sensor. Those are the two standard gases that we measure, regardless of what system you order. We also need supporting components to grab this sample from the animals, and so the entire gas intake system is included in both models. We also have a feed dispense system, which is, as Scott mentioned, it's used to bait the animals into the feeder. Depending on whether you order a pasture trailer or a freestall or tie stall cart, the power source will differ, but in either case, you'll have a way to power the system, whether it be using batteries or whether using a power source from the wall. And then finally, you'll get the cart or trailer, depending on your system. So it's a pretty much turnkey system that is all ready to go once you get it up and running. So no additional components are required for GreenFeed to operate. That being said, we do have optional equipment depending on if you want to sample different types of gases. We have an oxygen sensor, a hydrogen sensor. We also have an option for a dual hopper system so that you can feed different treatments to different animals depending on what treatment you want to dispense to them. If you're ordering a pasture trailer, you will have wind sensors included in the system, but if you are planning on using a freestall cart outside, then wind sensors are an optional equipment to purchase. We also have bird protection, which is usually helpful for if you have animals, specifically in South America, we found that really like to rip apart stuff. The bird protection is required to make sure that all the external wiring and components are safe. We also have a secondary webcam. So in addition to seeing the dish, a webcam pointed directly into the dish, you can also see kind of an overhead view of the whole area using the secondary webcam. And then finally, we have a cold weather kit, which is used for if you're really up north where it gets very cold in the winter. The dish can freeze over because it is metal, and special care has to be given to the electronics and the wiring to ensure that they don't get really, weather worn. And so we have the cold kit option, which if you're planning on using it in the winter in a very cold environment, that's required. The second part of the question is what support is offered. With the service contract that comes with your purchase, you get free phone and email support. We will replace anything that gets damaged due to normal wear and tear. And we monitor the systems on a daily basis to ensure that they're producing accurate results. So it's almost like having a friend on the phone that you can talk to anytime about the system. Then finally, what's changed in the new GreenFeed sensors? I'm not sure exactly what revision they're talking about, but the general layout of GreenFeed has been pretty much the same almost since the start. We found that from the very start, we chose a pretty robust system and set of sensors. So yes, the layout has changed a bit as we've gotten to know exactly the environments and stuff, but the general equipment that's used in the system has not changed a whole lot.
Mike, on the support, I might add that we also quality control the data and review the data for accuracy, which includes reviewing calibration results, outputs, and so forth. And also we provide the software as part of the support, along with the data archiving and so forth.
All right, Scott, do you want to go to your next question?
Sure, you bet. So the next question, I actually thought it was a really good one. GreenFeed seems largely applicable to research, but what is the application to large-scale commercial and dairy operations? So I think that's a great question. GreenFeed's been really in existence for around 10 years now, and most of the applications that GreenFeeds are being used to date are for research applications. So this question was, well, can it really be useful in a, production environment, more or less? So what we've learned over the last 10 years is actually that GreenFeed measurements are really highly correlated, especially carbon dioxide, in many cases with feed intake. And we have several papers out that are peer-reviewed that really look at the possible use of GreenFeed as a proxy for feed intake. So can we improve feed efficiency instead of by measuring every morsel of feed that the animals eat by using gas emissions than putting in like feed bunk type systems that actually directly measure feed intake? And if we can do that, it might be a lot easier to estimate feed intake in large herds because there's not nearly as much infrastructure required when you use a GreenFeed to measure, 20 to 60 animals compared to feed bunks, electronic feed bunks for every animal. So that's going to be one use. The second thing, in reference to large scale commercial operations would be, of course, phenotyping animals. There's been a couple presentations in the past. LIC in New Zealand gave a presentation last week on that work they're doing to improve genetics relative to methane emissions. And there's other groups in the world, in Ireland and Scandinavia and mainland Europe, who are really working to try and improve genetics relative to methane, and they're using GreenFeed for that. So that will definitely affect large-scale beef and dairy operations in the future. Having better genetics, as greenhouse requirements, gas emissions requirements, and political landscape continues to change, of course, GreenFeed can be used on large-scale applications just for inventory purposes or measuring or auditing the effects of treatments or carbon credits and so forth. The last thing is that methane and carbon dioxide are really representative of animal health. For example, methane decreases more and more. In individual animals, emissions rates decrease over time if they stop eating. So, for example, low methane emissions can be an indicator that there's a problem with that animal. So I think there's some other things that we're starting to learn from this GreenFeed data that could help enhance our understanding of animal health. So next question. Mike?
Mike, we can't hear you.
Sorry about that. All right, next question. Can you see my screen okay?
Yes.
Please run through the electronics, naming the components and what tasks they perform. Also, please show the flow of gas through the system. So this is a chance for me to show not just the components and how the gas flows, but pretty much every important piece of equipment on GreenFeed. So what I'm going to do here is just run through the basic flow of when an animal enters all the way down to where we sample the gas and everything. So on the left-hand side is where we're going to start. We have the animal first entering the system, and that's outlined here in gray. The animal will be wearing an ear tag, an electronic identification ear tag. And when they enter the system, they'll be picked up by this electronics identification antenna. And that's placed just on the roof of the feeding area. So we'll pick up their ear tag, in some cases a collar tag, but we also have a head sensor shown in black right here, and we sometimes refer to it as the nose position sensor. But that's how we can determine how close an animal is to the dish, so we can reliably ensure that we're capturing all that animal's breath. So when the animal comes up to the feeder, we'll pick up the ear tag, so we'll know who that animal is. We'll also see their head position, so we know how close they are. And at that point, while they're breathing into the system, the hopper will dispense feed, the correct attribution to that animal. So it'll bait them into the system and keep them there for roughly 3 to 5 minutes to get good, accurate data. While they're eating that bait, we have a fan up top here that's actually responsible for pulling air from the dish all the way up through this pipe and out. And I'm gonna walk through the airflow of it from the dish. It'll go in through the manifold and up into the primary air filter. That is very important to keep clean because we need a good airflow through the entire system to ensure that we capture the animal's breath reliably. So it'll go through this primary air filter, filtering out any of the huge debris that we don't want to clog in the system, and up through the pipe. We have some air mixing devices inside the pipe to make sure that we get a homogeneous mixture as it's flowing up through this pipe here. Next, it'll pass through this airflow sensor, which will determine how quickly that air is traveling, because part of the equation that you need in order to calculate emissions is you need to know the flow rate. And so this is what's responsible for measuring that flow rate coming from the animal. Finally, it'll be mixed up in this fan even more than just with the mixers. This fan is a squirrel cage fan, so it'll actually spin around, mixing the air even more before it throws it out of the fan outlet, the airflow outlet right here. But before it dispenses out the outlet here, we have a subsample that's taken right here. We have a tube that's actually protruding into this pipe here. And so we're going to go over to here now. Right before it goes exits out the pipe, the outlet, it's going to be pulled subsample back down, all the way back down into the electronics box. We do have a secondary sample filter right here to get rid of any small debris or anything that somehow got past the primary air filter. So there's a secondary air filter before it goes into the electronics box. All right, and so I'm going to jump into the electronics box here. Once it goes into the electronics box, it'll be coming in through this green tube right here, where it'll pass through a couple of solenoids that are responsible for calibrations. But normal intake will come straight through here, straight through some tubing, and into the first device here, which is labeled A, which is the main sample pump. So that is what was responsible for pulling the gas all the way from up here, all the way down into our electronics box. Once it's pulled in through the pump will then push the subsample into the main carbon dioxide and methane concentration sensor, which is this big metal box right here. That'll get our concentrations of the gases. So now we have the airflow and the concentrations, which are pretty much all we need to calculate the emissions. From that concentration sensor, once it's sampled, it then is pushed out into one of the optional equipment sensors here, which is labeled C, and that's that black device right here. And that's the hydrogen concentration sensor. So now we have methane, carbon dioxide, and now we have hydrogen. And then finally, once it's sampled there, it's then expelled out this exit port where it is released out the exit of GreenFeed. Now there is one T that if you have an oxygen sensor, which is another one of the optional components, the subsample before it actually goes in through the main pump, it'll be teed off into the oxygen subsystem. So it'll go into a smaller pump, which is labeled D in this picture. And from that smaller pump, it'll then go through some tubing and into our main oxygen sensor. So that will get the concentration of oxygen in our sample. Then finally, it's pushed through some more tubing and then all the way out through the exit. Some additional, so that covers the plumbing of where the gases are going through GreenFeed. But I'm going to point out some additional components here. We've already heard up through E here, which is the oxygen sensor. Labeled F here, this black board. This is pretty much the main computer that does all the processing. It controls picking up keeping the database of intake from the animals, which animals should get what feed. And its primary responsibility is recording the measurements and uploading the data to our server. The next device here is labeled in G, and that is the USB hub, because we have a few USB devices that connect to the whole system. And so this is just the hub that allows us to connect multiple devices to the system. Over here in H, this is one of the optional equipment, one of the optional devices, and this is the modem. So if you're going to have a GreenFeed in an area where you don't have any Wi-Fi, Wi-Fi network or Ethernet options, we can supply you with a modem so that when you're out on a pasture trailer, it can still collect data through a cellular network rather than Wi-Fi or through your infrastructure's network. In the far upper right corner here, we have item I, which is a power converter, because that fan that's on the very top of GreenFeed requires a little bit more power than most of the other equipment. So this power converter will actually supply that extra power needed to run the fan. And finally, labeled J here, this is the intake tubes for when we're running auto calibrations. And that will be in another question coming up soon. But these two blue tubes are for auto calibrations, whereas this main green tube is for sampling animals. And then here's a photo of everything without my markups on it in case you're interested in seeing the whole box. All right, Scott, you're up.
Okay, so the next question is how to best operate an outdoor green feed comment, especially in the winter. So basically an outdoor green feed, the biggest difference between outdoor and indoor is you need a power source to run the green feed if you don't have AC line power available. Generally, the way power is supplied to outdoor green feeds is through solar panels. So we have a couple solar panels mounted on a trailer system. You put the green feed onto the trailer, like what Mike was showing before. In the summer months, those solar panels will provide enough power to keep green feed running. In the winter time, especially at northern or southern latitudes, you might not have enough power to keep the green feed running because the solar power in the winter can be, in some cases 8 or 10 times less than in the summer. So in the winter months, you may need a supplemental power supply like a generator or a petrol or gasoline power generator or something like that. Or with our box and green feed, you can plug it into AC line power to operate the system. So operating outdoors is just basically trying to power the unit. We also have green feed systems that instead of solar power, they use a generator. And so when green feed senses the battery power is low, it will automatically turn on a gasoline generator. The generator will turn on for an hour to charge up the batteries and then turn off itself. And this is a little bit better if you're in a climate that's cloudy or has low solar power or so forth. The other thing about the winter is that if you have below freezing temperatures, ice can cause problems on the manifold and build up, and the system won't work. So in very cold temperatures, we have to use heaters that apply a lot of power to the system to keep things thawed out and keep ice from forming on the feed intake manifold and the various sensors. When you have that heater, the power requirements for that heater are somewhat large, so there's no chance of being able to run the heater system using the solar power you would have in the winter. So in order to sample outdoors in the winter in very cold temperatures, you really have to have an AC line power source where you can plug the unit into power to keep the unit running. Probably the only other major consideration for outdoors is we found that the gas emissions can be diluted by wind. So in other words, gas, instead of going into the green feed, blows out of their nose and isn't measured. So we can account for that sample loss, but we really need wind sensors on the unit. Anytime indoors or outdoors, that it's going to be windy so that we can account for wind effects. So next question.
All right, the next question is, how often does GreenFeed auto-calibrate, and how does the auto-calibration system work? Generally, with the auto-calibration system, we run it once every 3 days. In some cases, we can run it, it's automatically, so we can control it whenever we wish to. But for a good measurement system on a trial or experiment, 3 days is usually a good interval to run auto-calibrate. So that's the easy question, but the next question is, how does the auto-calibration system work? That is 2 tanks connected to it. Every sensor, from a therm scale to a thermometer to concentration sensors, they will report the values that they're receiving just as a value. That's it doesn't have any labels behind it or anything. It's our job to convert those labels into a meaningful human readable label, such as kilograms or degrees Fahrenheit or Celsius, or in this case, parts per million. So what we need to do is, even though the sensor can read concentrations, we have to first train it to know what a zero gas is and what 1000 ppm gas is. So we connect two gas tanks to the system. One, it actually doesn't matter if it's a zero tank, but a zero concentration, zero methane and zero carbon dioxide is a lot cheaper than a non-zero mix. And so we'll connect pretty much just a nitrogen and oxygen mixed gas as the zero tank. And that will run into GreenFeed for somewhere between 60 seconds to about 120 seconds. So 1 to 2, in some cases 3 minutes. That's actually shown here. So in the graph below here, we have this red line, which indicates just the output of the concentration sensor. And you can see that it's a nice steady line because no animals are visiting. We're just getting background concentration of the air. And then the zero is fed in. So this concentration sensor will output a lower value. And again, that's just a value that doesn't have any parts per million behind it or anything. It's just a value. It's a relative value that we can see on a graph very easily. Once the gas is finished running through the zero, then we run the exact same procedure. We'll run a span gas, and in this case, it's 1,000 parts per million methane. So from these two, zero gas and a span gas, we can get what we call the calibration factor, and that will be I'll run through here. Here's the zero, the span. Basically, to calculate the calibration factor, we need to do the difference in the parts per million of our gas, so the span parts per million minus the zero parts per million, divided by the raw sensor output difference. So in this example, you can see it's 1,000 ppm minus our 0 ppm divided by the sensor response, which is 1290 minus 270, which gives us, if you calculate it out, about 0.98 part per million per raw sensor response. So that, in this example, that just means that every one sensor point above the baseline value equates to 0.98 parts per million CO2 above ambient air.
Okay, thank you, Mike. So the next question is, could it work for other species and also measuring ammonia and nitrous oxide? So as Mike discussed earlier, and I discussed, generally the gases we measure in GreenFeed are methane, carbon dioxide, oxygen, and hydrogen. We definitely, if sensors exist that are able to measure whatever gas that you would like to measure, we can integrate other sensors into GreenFeed and potentially measure the flux of those gases from the animals. There's a lot of different sensors out there, and depending on the gases you would want to measure in the range, it may or may not be feasible to integrate them into GreenFeed, but it might be possible. If, for example, you were interested in, so the GreenFeed also only measures the mass flux from the animal while they visit the unit. So say GreenFeed was in a barn and you were interested in ammonia emissions rates from the barn. GreenFeed wouldn't be able to measure the ammonia emissions rates in total from the barn. It really only measures the emissions from their mouth. So, but it could measure the concentrations of ammonia in the barn at any given time and give you some idea how the concentrations in the barn change, but it couldn't give you the mass emitted. But definitely it's flexible, and there's different alternatives, and if you had a project that you were thinking about, feel free to contact us. GreenFeed's been used with goat, sheep, cattle, and actually a lot of different kinds of cattle. Potentially it could work for maybe measuring energetics and metabolism in other types of animals with oxygen and methane. For example, pigs, oxygen and carbon dioxide. For example, in pigs, maybe I realize horses aren't a ruminant, but they do emit a little bit of methane, maybe in horses and so forth. But so there might be some opportunity to use it sort of as an indirect calorimetry system for other animals. But we really haven't used GreenFeed for non-ruminant animals at this point. And while I'm here, I'll just take the next one really quick. Can GreenFeed be used as a solution to quantify methane emissions reductions in a cost-effective way so ranchers can earn carbon credits? Sure, it could. The way I would use GreenFeed for any carbon credit program would be on a either validation or audit basis. So basically, if you have different treatments or so forth, in a short-term way, you can verify reductions or baselines and so forth. And then in order to make it cost-effective, I would actually just use the GreenFeeds and rotate them between projects. You don't necessarily need to measure every single animal every single day in order to have a verified carbon credit. You could use it for auditing or verification on shorter term basis. That way it could be used for more projects to kind of spread out the cost. So go ahead, Mike.
The next question is what GreenFeed maintenance is required and how often? And I'll run through these. These are the general procedures that are required on a scheduled basis. Cleaning the air filter, one of the most important things. This should be done about once per week of GreenFeed operation. The caveats to that is when your airflow on standard GreenFeed gets below 27 liters per second, you should swap out your air filters. For small animal GreenFeed, that should be somewhere in the 7 liters per second airflow range. And as your air filters get used more and more and more, they'll get dirtier and dirtier, and you'll have to swap them out more often. And after about a year, we usually recommend you replace the air filters altogether. The next up is performing a CO2 recovery, which is very important when you're running an experiment. So we recommend that you do it once before your experiment, just to test and get a baseline, know that the equipment's working correctly, and then once per month during your trial. Standard calibrations, as we mentioned before, you'll want to run those approximately once every 3 days, but if you have an auto calibration system, you don't need to worry about that. Filling the hopper bin, it really depends on the density of your feed, but somewhere in the vicinity of every 1,500 to 2,500 drops. So some people about a week, some people a month, just depends on how much use there is. You'll also need to clean the nose position sensor, which is directly above the dish. It really depends on how dirty the barn is or how much the animals lick it, but we recommend checking it once per week and cleaning it if you get an email alert about it. And finally, replacing the secondary sample filter, we recommend doing that once per year of operation. Or if you get a really dirty barn, it could be more often than that. I do have this URL that shows you all the maintenance, how to perform it under this link. So pause the video or take a screenshot of this and you can see all our YouTube videos on how to do maintenance. All right, Scott.
Okay, so the next question is what steps are taken during the final review of the data? Can you explain the different sheets in the summary file? Unfortunately, I don't think I have time to dive into the summary file. This individual, I'm happy to have a webinar or so forth to go through the various sheets in the data. But I can describe at a high level what the data review process is. First, when we review your data, we review the calibration results for variation and accuracy or anything unexpected. Concentration calibrations and then recoveries. Then the data out is output, and we review the data, really look over it for any of our automated flags that have come up, and we also review the data by eye. But you know, after 10 years of reviewing GreenFeed data, we have a pretty good idea when there's problems or not by looking at the data. And then that's performed by Howland first, one of our data people, and then when he gets to a point where the data looks okay to him, I'll perform the same steps looking over the data. Once the data looks okay, the preliminary data is, so we have two steps. We have preliminary data and then finalized. The preliminary data is output automatically by the processor and available to the client almost on a real-time basis, but then we go through the secondary steps where we actually review the data ourselves, and then once that date range of data is reviewed, we call that finalized. And once it's finalized, we'll notify you of where to find the data, and you can download it for your own consumption. And then the next question, I'll just answer right now so we don't go back and forth. What are the measures in place to ensure that frequent animal contact and also to generate reliable data sets with time? So some of the reliability and monitoring, of course, we've covered a little bit with accuracy of calibrations, monitoring the unit for problems and so forth. If we can make sure the data that's collected is functional and accurate, we can ensure that the data that's output is going to be accurate. In terms of frequent animal contact, in other words, I take this question as, how do we know we're measuring the animals enough to have a reliable estimate of emissions? Of course, the feed and baiting structure and schedule used in GreenFeed is important so that you can get animals there. Ideally, for an individual animal's emissions, we'd want to get them to the unit 20 or 30 times in order to have reasonably accurate of their average emissions over that time. So basically, both the users and CLAC have to review the data and make sure that the experiment is set up in a way that really enhances the animals to wanting to use the GreenFeed on, you know, a 2 or 3 times per day basis, so that we can collect those 20 to 30 measurements over a week or two. So Mike, go ahead.
All right, next question. How many animals do you suggest for each study? A general rule of thumb is for pasture systems, 15 to 20, and for freestall, 20 to 40. But again, that's just a rule of thumb. Some people have attempted over 100 in a production dairy and over 300 on pasture. But this will just result in not enough visit times at the feeder. And so if you do try to increase the number of a number of animals in the system, you just won't be able to sample some of the animals or not sample as frequently. Do you have anything to add to that, Scott?
Nope, that sounds good. It's a little bit variable. Like what Mike said, as you add more animals per unit, you'll get fewer samples, especially for the shy animals. So it depends a lot on your project and its setup and what you're trying to accomplish. But these are great rules of thumb. So I guess go ahead and if our audience has questions, go ahead and submit them to us, and we'll start answering them.
Okay, we did have a couple come in just yesterday, and I haven't added them to the slides here, but one question, how often do we need to clean filter? We already mentioned that about once per week, but as they get older, you'll have to clean them more often. Do we need to adjust the flow rate of GreenFeed for small cattle, 300 to 350 kilograms? The answer is that we have a GreenFeed for small animals specifically, and that's a much smaller fan. So you'll have somewhere along the lines of 6 to 15 liters per second rather than 30 to 50 liters per second. And using standard size GreenFeed on smaller animals is not recommended. I also have this URL here for seeing the small animal GreenFeed. So either screenshot that or pause the video if you're watching this later. All right, let me pull up these questions.
So Do we need to adjust for small cattle? So the way I would approach that is our current GreenFeed systems allow us to measure cattle that are emitting about 40 to 60 grams per day or more. We could decrease the flow rate and maybe improve that. It's a long story, but when we decrease the flow rate, we cause more problems. In some cases, we can have additional sample loss. So it's really, I wouldn't say we can't use it for small animals, but I would say if you're applying a GreenFeed to uses that are not standard, feel free to contact us, and we'll work with you to kind of figure out what each size of GreenFeed is best for you, and what it can and cannot do. So I would say just feel free to contact us, and we'll help work on designing an experiment that will be successful.
Okay, so I'm going to read through these questions that just came in. Is NH3 ammonia sensors available? And Scott, you did allude to that a little bit, ammonia sensors.
So ammonia, we have not tried to measure it in GreenFeed at this point. So, and that would, if we did measure it in GreenFeed, it would either give us the concentrations of ammonia in the barn or the actual ammonia emissions from the animals. If there's interest, that's something that, you know, we might be willing to look at, but certainly any gas may or may not have the potential to be measured in GreenFeed, depending on the available sensors and the concentration ranges and so forth.
Okay, next question. Are hydrogen emission measurements also accurate, or any different calibrations need to be done?
So of all the sensors we have, the hydrogen measurements tend to be a little bit more difficult than either methane, oxygen, or carbon dioxide. The hydrogen sensors have a little bit slower response time and have to be calibrated a little bit differently, and they can be a little bit sensitive to moisture. The hydrogen measurements are very effective at telling us whether or not some of these inhibitors are working, because the inhibitors have a very strong influence on hydrogen emissions, and oftentimes the hydrogen emissions from the inhibitors are, you know, maybe 10 times as much as not having the inhibitor. So I would view hydrogen emissions, and we've also done recoveries with hydrogen in our lab and so forth to show that the emissions rates from our sensors match what we actually inject with hydrogen. But of all the sensors, I would say, you know, with methane, carbon dioxide, plus or minus 5% on accuracy, oxygen is in that plus or minus 5%, hydrogen might be in that plus or minus 10 to 20% range. So that there's more uncertainty with hydrogen than other gases.
Okay, next question. I'm not quite sure what they mean, but how can power supply be insured in case of pastures? And I think they're asking based on batteries. The answer to that is it's really dependent on the sun. You need sun in order to produce solar power. So if you are running on solar panels, they need to be clean, and you need to have them pointed in the right area. And even then, it's not a guarantee because of cloudy days. So if you're running a trial on a pasture with solar panel, having an alternate option such as a remote start generator, we can retrofit remote start generators into the system as a backup for power supply.
The other thing is that you're able to plug in a power source into the GreenFeed pasture trailer if solar gets low. So for example, you can go purchase a small handheld generator that starts with a pull cord, take it out to the unit. You'll get an email that voltage is low. So voltage is low, you can take your generator out to the unit, charge that battery up, and it'll allow you to run for a couple more days.
Okay, we had a couple questions about the cost of GreenFeed, different configurations. I would suggest contact sales@clockinc.com and they can get you a quote without any commitment, so you can get a general price overview. How much time per animal day required to measure amount of methane production per day? In one GreenFeed, how many animals methane can be measured? I think we answered that. General rule of thumb, in a freestall scenario, somewhere in the 20 to 40 range. Let's see here. Is there any?
So I'll
sorry.
elaborate on that. We didn't answer the time. So we want to measure the animals. We usually have a 2-minute or 3-minute cutoff. And once we, especially on these forage-based diets, once we measure an animal 2 or 3 minutes, there's only marginal improvements and not statistically significant improvements for measuring them longer. So say like 10 or 15 minutes. And then we want to collect those measurements, 20 or 30 measurements from the animals over time. And we found that that's actually very effective of giving us an overall average estimate of that animal's emissions over the whole entire day.
Okay, and this question is pretty kind of related. Is there any time limitation between animal visits to the GreenFeed station? I'll just add to what Scott said that you can actually specify how often you want animals to visit based on when they're fed. So you can set it so that animals can only visit the feeder 4 times throughout the day, spaced 6 hours apart. So you can kind of regulate when animals are allowed to visit based on when you're dropping feed for them.
And I would also point out that if you have these green feeds in a crowded, say, freestall facility, and you have a lot of animals using the green feed all the time and variable background conditions, so we have to subtract out the response from the animal from the background concentrations of methane. And so green feed needs maybe 30 seconds periodically of no animal use in order to measure the background and approximate it. So if you put it in a highly populated barn where green feed's getting used continuously and you have variable concentrations, that can affect the accuracy. So that would be another considerations of the number of animals per unit that are allowed to use it.
Okay, next question, and this one's pretty exciting for me. Do you plan to set up recovery check procedures for other gases such as O2? Scott, do you want to take this one?
So we're developing for methane recovery system that we can provide. So we can check CO2, methane. We potentially could do the same thing with oxygen. The challenges of measuring recovery from other gases are that generally you have to perform those recoveries. So those gases are not, they're gases at room temperature, even if in compressed form. So we can't get a high gas density in a small convenient package like we can CO2. So you have to purchase great big bottles. And then when you have a great big bottle, you have small release rates into the green feed, and we're trying to measure small release differences from a big bottle, which is challenging from an accuracy standpoint. And you also have to occupy the green feed for a period of hours in conditions where the animals can't use it. So yeah, it can get pretty challenging to do methane and oxygen recoveries in these installations where they're sort of in a set place in a barn. There's a lot of animals around, and it's hard to get a high precision scale in there. But we are developing a system. The idea is that the recovery is actually more accurate and provides us more information than our current system. And our current system actually is really highly accurate the way we do it. So it will have some use, but we don't want to impart more error by trying to do recovery just because of all the things I mentioned than just using the current system. So there'll be a possibility. It's not going to in my opinion, it will be a verification and not going to really change our current calibrations techniques, because I think in most applications, it can't enhance our accuracy anyway.
Okay. Next question here is, they're basically asking something about the tracer, saying that it's difficult to get into the machine where they have it. I will say that the propane tank, we have actually obsoleted, so you actually don't need the propane tracer anymore. So if it is in your way, you can remove that propane tank, and that'll free up some space and you won't have to replace it anymore. Next question, how is it possible that having set up for the system for a max of 6 visits per day, I finally have up to 15 to 20 visits for some animals in my validated data? Not quite sure what, maybe we can contact them after.
So the validated data doesn't take into account the feed drops. It just says, is the animal there for two minutes using the green feed with its head in. So potentially you might have the unit drop feed for, say, 4 visits. But if that animal's in that green feed all the time for other reasons, like just licking or so forth, you could get more visits output for that animal in terms of fluxes. So the fluxes are independent of the dropping. And when the data is output, it's just looking for, is that animal there, and is their head in, and is that data useful? It doesn't, the algorithm really doesn't care whether or not food was dropped at that time. So oftentimes or vice versa, if food was dropped, that animal was not behaved, and the animal pulls its head in and out, and you can't get good data, that visit data wouldn't be output. So most of the time, the users will get different number of validated visits than number of visits that gave food drops.
All right, next question. Is the power source also used as source of light during the nighttime so that animals on pasture can eat from it? I think they're wondering about the dome light. You can configure the dome light to turn on all the time, and it doesn't use much power. So even on a pasture trailer where you're using the batteries, you can leave that light on safely. And if you're wondering how to do that, feel free to contact us at support@clockinc.com. We can show you how to do that. Next question. How does it work with already installed concentrate feeders? Do the animals visit GreenFeed? Scott, you want to take this?
So say you're in like a dairy system or a dairy barn where they have a concentrate feeder giving, let's say, 3.5 kilos of feed per animal per day to the feeder. Generally what people will do is, we found it hard to sometimes work with those companies to kind of share concentrate between the feeders so that all the feeders from different brands or different manufacturers can be on the same schedule. So generally what you do is, if you're feeding the animals 3.5 kilos per day normally, you would decrease that in your concentrate feeders to 2.5 kilos per day, and then you would use green feed to deliver the extra kilo. So they're still getting 3.5 kilos. They get 1 from the green feed and then 2.5 from the concentrate feeders. And generally these, like a dairy animal, they're going to figure it out, and you shouldn't have a really decrease in concentrate for animals, and it still should be pretty consistent for concentrate intake.
All right, next question. This is actually a really interesting one. Is manually bringing a cow to use the machine at the same time every day biasing her measurements?
Definitely it could. So methane emissions do fluctuate over the day, and there's a diurnal pattern. I think that diurnal pattern is not as strong as a lot of people think it is, but it still occurs. When animals are allowed to use it kind of voluntarily, what we find it, because we use like 4-hour spacing and animals can't keep track of time and so forth, exactly, they'll generally space their visits out voluntarily enough so we can get a really accurate picture of the diurnal pattern over a number of days. But certainly if the animals for whatever reason are only allowed to use it during like 1 hour of the day, and say it's the lowest or highest time of the day, you could have bias in that measurement, because if it's at the same time every day, you could always be measuring at the absolute low or high or so forth. So you could have bias. Probably that bias is going to be on average plus or minus maybe 20% uncertainty compared to the daily emission. So it's not going to be a huge difference, but of course 20 or 30% can be a significant amount. So if you're doing that, and also if you go submit a paper for review and the reviewers ask, they may not like that. So if you're doing that, I would recommend trying to get a better picture of what's going on with the diurnal pattern.
All right, next question. For how long should the animals be trained? And I think this kind of, we covered this in a previous presentation. A majority of them will pick it up within the first, I'd say, week. Probably about 25% of them will pick it up almost right away within, a couple of days of being at the feeder. And then you'll have a small portion, somewhere between 10 and 20%, that just either they're not dominant animals and they just will not use the feeder. Scott, do you have anything to add to that? How long to train animals?
There's different training protocol depending on your system, and I would say if you have questions about training to contact us. But I would say in general, animals can get trained to use the system in 1 to 2 weeks. And if they're not using it in 2 weeks, sometimes you have to apply different techniques to get them to use it. But if you're having trouble with training, feel free to contact us and we might be able to help.
Okay, just a couple more questions here. When I talked about the cold temperature kit, they're wondering what temperature range is that, specifically minus 15 degrees Celsius in Northern Europe. We're thinking more like in the negative 30, but the general rule of thumb is if just animals breathing on the dish will cause it to completely ice over so that the manifold can't collect air, that's when you would need the cold weather dish heater.
So if it's going to be below freezing for the whole day or a period of days, and you think that time below freezing is important to your experiment, of course we can throw out the data if it's below 0 and it's not working. But if you want to have an experiment that's prolonged over really below freezing weather, you would need the manifold. And in terms of, or the heated components, in terms of like minimum temperature, we've operated the GreenFeed in up to say 30 or 33 below Celsius. So, and it's still functioning. So I think anywhere there's ruminant animals that are able to survive, if you have the heated components, it should function just fine.
Okay, next question. How do you combat diurnal patterns in animals not being fed ad lib during the test period? How to factor in behavior of animals who may visit the machine at the same time every day?
Good. Combat is an interesting word. I don't really view it that way. I would just let them use it every 3 hours or 4 hours, and over time, if you let them use it a week, each measurement will vary periodically, and you'll get a really accurate picture of the diurnal pattern. In general, I feel like the diurnal pattern issue is way overstated, and it's not a significant problem with GreenFeed, and it's not a significant source of error. It's sort of a red herring. If you want to get accurate measurements with GreenFeed, focusing on calibrations, making sure the unit's running, making sure the data is coming in is by far the most important. And if you allow the animals to use it every 3 to 6 hours, regardless of how you feed them, you're going to get actually a really accurate picture of methane emissions over time. And that's
Okay,
go ahead.
We have more questions coming in. Scott, are you okay to go
Sure,
a few
let's
more
do
minutes?
a couple more. Yeah.
Okay. What minimal number of days is required for reasonable CH4 estimates?
Like I said, 20 to 30 measurements. If you measure 3 times a day, that would be 1 week. If you measure twice a day, maybe 2 or 1.5 times 2 weeks. So we want to pick a time when conditions are somewhat stable. If your conditions are changing very quickly, for whatever reason, like you're changing diets and you want to capture that change, you would have to measure them more frequently over the day. If you have static conditions where, you know, feed intake day to day is consistent, then you can measure them less frequently and measure them over a longer time period. So that's like in order to get a estimate of emissions from that time from that animal. There's a second question, like if you're phenotyping an animal, how long do I need to measure them? And that's really not been defined, and there's no standard protocol for phenotyping animals for methane. Different organizations are doing different things, but generally what we see is the variance in methane emissions is somewhat similar to variance in feed intake. And if you perform methane measurements the same way as a recommended feed efficiency test over the same number of days, you should have some valid estimate of methane emissions for a phenotype. But there's still a lot of discussion on that specifically.
Okay, next question. Is raw data available to view, download directly from unit? What I would say is, yes, there is a possibility to download the data directly from the unit, but then we're at the mercy of having to go out to the feeder, download it onto USB, and then return and send it to us. What we should address is why the unit isn't uploading that data. Most likely a cellular network isn't very strong in that area, or for some reason the modem or Wi-Fi network isn't able to connect. So it is possible, but we highly discourage doing it. We would much rather have the feeder always online uploading data so you don't have to go to that extra step. And oops, final question. Do I have to explicitly ask for a review of the raw data, or will that happen automatically after some time? And I'll say that we do have a pre-experiment checklist that we usually ask you to fill out, and that's just so we know when your trial is, when it's starting and when it's ending, and how often you want the data. It has quite a few more questions just so we don't have to do a back and forth through email. But if you do put in there that you would like, you know, weekly data reviews, we can certainly do that. Scott, anything to add to that?
Nope, good answer.
Okay. And finally, I think we're going to cut the questions here. There's one more. What do you recommend in the case of cows not visiting frequently enough? Increase the number of allowed visits or shorten the interval?
So if you want to collect more measurements per day, you would shorten the interval would probably be the best way to approach that. Generally, I mean, it depends on every application, but if you can get them to the GreenFeed 2 to 3 times per day, there's actually been really quality work published with like only 1.4 times per day visits. You should have enough. So it really depends on your application and what you need to do. But if you feel like you need more measurements in a day, I would shorten the time between the visits.
All right, well, no more questions came in. So if you do think of questions, you can always either email contact@clockinc.com for general questions, or if you have support related questions, email support@clockinc.com.
Thank you everybody for attending and listening to this webinar. We really appreciate all of our users' patience and really the innovative research that's being done with the GreenFeed and the equipment. Of course, if you have any other questions, feel free to email us or give us a call. We're always happy and anxious to talk about the GreenFeed. So I hope everyone has a great day and keep up the good work. Thank you.
Stay safe, everybody. Thanks.